Okay, this is Math 2. We're going to do 70, 71, and 72. And 70 should go pretty quickly because the hint online is pretty self-sufficient. It says, assume in the diagram at the right that measure of angle ECB is going to be equal to measure of angle EAD. So that's our given, because it actually gives you that information in the picture. So ECB, so this one right here. And then that's congruent to EAD, this one right here. All right. And point E is in the midpoint, or is the midpoint of EC. So point E is the midpoint, which basically tells us that this part right here is going to be the same as that. Okay, that's this part right here. That's this information over here. So you really only had two givens, which is those two right there. And then it says that AED is equal to CEB, which gives you this angle right here is congruent to this angle right there, since they're vertical angles. And so now you have angle, the blue angle, this red side in the middle, and then the green angle. So blue, red, green. So we have angle, side angle. And then you have that AD is congruent to CB as a line segment, because congruent parts, or congruent triangles, give you congruent parts. Okay, that was 70. 71 is a little bit more complicated. So let's do information that we know first. So in this case, a sector is attached to a side of a parallelogram. So if you can think of a sector as this part, this is your sector, right? I'm going to just lightly shade it so you understand what I'm talking about. That's your sector. And then it's attached to a side of a parallelogram. So there's a couple of pieces of information that you do know. You know that 15 is the side of this parallelogram down here. So that means that 15 is going to also be the top of the parallelogram, since opposite sides are congruent. This from this corner here to here is 12. And so if you can think of it like a radius of a circle, which is really what it is, since this is a sector, then since that is a radius of a circle, and I guess you could think of the circle as, well, I guess we're kind of going this way here. Wow, this is horrible, but that's okay. There's a circle. It's not exactly drawn to scale, but you get the hint. And since this radius is 12, this over here is actually another radius. It's also 12 inches. And so that means this part is 12 inches also. Now, that almost takes care of the perimeter and almost takes care of the area, but not quite. So let's do the perimeter first. This is 15, that's 12, that's 15, that's 12. We need this part. So how much is it from here all the way down there? And that's technically, since we're looking for the perimeter of a circle, that's technically like finding the circumference of the circle. And we only need this part, so we really just need the arc length. So in a circle, I'm just going to draw it right here. You have, here's 12 and 12. You have 60 degrees as your central angle. So you really want the arc length. Well, technically, it's 360, right? And there are, how many 60s in 360? 360 divided by 60. There's 6 of them. All right. Well, if you find the entire circumference of the circle, then divide by 6, you'll get the arc length, which is that missing, which is technically the crust of that pizza. So 360 divided by 60 is equal to 6, right? So there's technically like 6 slices of this pizza in here. So the circumference is 2 pi times your radius. So your circumference of the entire circle is 2 times 12 times pi. So 2 times 12 is 24 pi. So 24 pi. So 24 pi divided by 6, because there's 6 slices in there, should give you 4 pi. So the arc length is going to be equal to 4 pi. I think we're in inches, right? We're in inches. So this one right here, the length between this point to this point, if you were actually to take a tape measure and measure it out, is 4 pi. All right, so that's, let's see, around 4 times pi, that's going to be somewhere around 12.6-ish, all right, which is roughly around 12.6. 12.6. So your perimeter is just adding them all up. So we have 12 plus 12 plus 15 plus 15. Oh, no, this is just one 12, my bad. Sorry, 12 plus 12. No, there's still two 12s. Plus 12, that's 12 right here, plus 12.6-ish. And that should add up to, let's see, 24 plus 30 plus 12.6. Oh, perfect. 66.6 inches. That's our perimeter. Sorry if you couldn't see that. 66.6 inches. So we had 15 plus 15 plus 12 plus this 12. That's the perimeter, right? The outside pieces. So we use the circumference. The arc length of this little part right here was 4 pi, or known as 12.6. Okay, now the area. The area of the sector should probably kind of be easier to find. The area of the parallelogram, the formula was, area for the parallelogram was just the same as the area for a rectangle or a square, so it's just base times the height. The problem is we don't really have the height of this yet. We have the base, but we can find it, I promise. So here's what I'm going to zoom in on, because we're going to work primarily with knowing the fact that this is 12 right here. We need to find the height, and the height is really going, it's not going, it's going to be at a perpendicular from like that. All right, so we know this is 60 degrees. All right, this is obviously 90 degrees up here also, but what concerns us is this part right here. I'm going to take this triangle, this right triangle, and I'm going to take it out. Well, what I mean by out, I'm just going to redraw it right here. Okay. So this was 60 degrees, and I know this is a right angle right in here. So if this part is 60, then this remaining piece, the one my pencil is on right now, has to be 30 degrees, because they make a right angle. So we have 12 as the hypotenuse, and now what we really need is the height. So I'm going to call this part x right here, because we want the height. So there's actually no other way to do this without using trig. There's just no way. So if I'm at 30 degrees, my hypotenuse is 12, and then across is nothing, right? Opposite is nothing, so that means I'm left with adjacent. And adjacent and hypotenuse, hopefully you've realized now, is cosine of 30 degrees, is going to be your adjacent over hypotenuse, so x over 12. Cosine of 30 degrees, and I'm going to do this in decimals because it'll make your life a little easier. Cosine of 30 degrees is going to be 8.66, so 0.866 is equal to x over 12 over 1, so multiply this by 12, and we get that x is equal to around 10 points. I'm going to say 39. I'm not going to round to 0.4 yet. Let's go with 39. Oh, 392, actually. That's even better. Okay, so x, this part right here, is actually the height of this triangle. So 10.392 is the height of that triangle. So if we go for the area of just the parallelogram, we have area is equal to the base, which is 15, times the height, which is 10.392. So area of the parallelogram is equal to times 15, so 155.8846. Let's say 8846. All right. Now we need the area of the sector. All right, so I'm going to do a little. I'm going to partition off my work here. So area of the sector, so we had area of the circle, just in general. If I had a circle with a radius of 12, that would be pi r squared, so pi times your radius, which is 12 squared, so 144 pi. All right, but I only want, there's six slices in here, so I only want one of the slices. So if I know the area of the whole pizza, 144 pi, well, I'm just going to divide by 6, and 144 divided by 6 is better known as 24 pi. So one slice of pizza in here has an area of 24 pi inches squared. And 24 times pi is just around 75.4 inches squared. Actually, more like 398. 75.398. Okay, that's better. Inches squared. So the area of this slice of pizza is 75.398 inches squared. The area of the parallelogram is 155.8846 inches squared, because we're still in inches squared. So I'm going to add those two together, 75.398 inches squared, and the area of the total, which is the parallelogram, and the sector of the circle, is going to be 155.8846. Somewhere around 231.28. I'm going to round to 283 inches squared. All right, that was very complicated. Okay, so there you go. 72 now is a probability question. A snack cracker company conducted a test for 3 different types of crackers that it makes. They should probably put a that in the sentence. It surveyed 250 people in each age group. Oh, so we know our total is 250. Okay, that makes our lives a little bit easier. So 250 total. Participants choose their favorite type of cracker. Use the results to answer the questions. Okay, so I'm gonna add these up. Sorry, you're gonna have to wait because I don't really like to do this without adding things up. So we have 44 plus 54 plus 152. Wait, what? 44 plus 54 plus 152. 107 plus 85 plus 58. Why are they all adding plus? That's not good. All right, well, we know there's 250 people. Can't all be. Oh, 250 people in each age group. Oh my goodness. Okay, so 250 in each age group, 250 in each age group. Oh my god, that's not 250 people. Ooh, common misconception right there. 4 times 250, so it really surveyed 1,000 people. Okay, that makes more sense. So 250 in each age group. Wow, that was confusing. Okay, so 1,000 people total. And then we want to know how many cracker A, how many cracker B, how many cracker C. So 152 plus 107 plus 78 plus 34 is 371 people preferred cracker A. 54 plus 85 plus 101 plus 68. 308 people would like cracker B. 44 plus 58 plus 71 plus 148. So that's 321 plus 308 plus 371 should give you 1,000. Okay, perfect. Okay, so totals. All right, what is the probability that a participant choose cracker A or was under 20 years old? Use the addition rule. Okay, so the addition rule basically says add up everyone in cracker A, add up everyone who was under 20 years old, and then subtract what you have in the middle. So everyone for cracker A plus, so the probability of just cracker A plus the probability of under 20 minus probability of A cracker and under 20. Okay, so everyone for cracker A was 371. Everyone under 20 was, well, 250. That really didn't change. Minus, take out what we have. That's the same in both, minus 152. So 371 plus 250 minus 152 should give us 469. So 469 people out of 1,000 people either chose cracker A or was under 20 years old. So 469 divided by 1,000 should be somewhere roughly around 46.9% of the population. Or out of your sample pool, I should say. Okay, now, the other way to do the OR is if you shade everyone who's in cracker A, if you shade everyone who's under 20, you really shaded 1, 2, 3, 4, 5, 6. If you add up all 6 of them, you should still get the same amount, 469. Okay, next one. But using the addition rule, well, this is it right here. What is the probability that a participant did not choose cracker A and was over 20 years old? Use the complement to answer this question. Well, basically it just means use part A to answer the question. So if you know that this number of people, 469, did not choose cracker A, or they were under 20 years old, everybody else should be either choosing cracker B or C, and they were over 20 years old. So if you just take 1,000 minus 469, you're left with whoever didn't choose cracker A and they were over the age of 20. So 1,000 minus 469 should give you 531. So 531 out of 1,000 people did not choose cracker A and they were over 20 years old. Okay, so that's what, 53.1%. All right, what is the probability that a participant was 20 years old or older? Okay, so 20 or older, basically it's these three, isn't it? So 250 plus 250 plus 250. All right, so 3 times. Use a complement to answer this question. So if you know 250 was under 20, then everybody else was pretty much over 250. So 250 or 1,000 minus 250, whatever's left over, which is just 750 people out of 1,000 people. Around 75% of your population was over the age, or 20 years old or older. Okay, so a randomly selected participant says he is 15 years old. Okay, so that puts him under 20. What is the probability that he chose cracker A? He is 15 years old. Okay, so he's under 20, obviously, and he chose cracker A. So that would make him 152 people fall in that category. So 152 people out of 1,000 people. So that's 15.2% is your probability. Okay. All right. So that was 70 through 72. If you need additional help, you can see me after school.